Hello everyone! In this video, we're going to go over the KutaSoftware Infinite PreAlgebra free worksheet one-step equations with fractions. Very similar to the one-step equations with decimals and the one-step equations with integers, except we're just working with fractions. So let's dive into number one. Remember, our goal in this is to isolate our variable, and in the case of number one, that variable you can see is p. So if we're isolating p, how do we get rid of this 5.5? Well, we're just going to move it to the other side of the equation. And because it's technically added with p, then we're just going to subtract 5 and 1/2 from both sides. So if we subtract 5 and 1/2 from both sides, 5 and 1/2 minus 5 and 1/2 is 0, and 0 plus p equals 6 minus 5.5. 0 plus p, that's why we subtracted that 5.5, because when we add those two together, it gets 0, and 0 plus anything is whatever that 0 is added to. So it's just going to be p. So there we have it. You can see we've isolated our variable, and now we're just going to subtract on the right-hand side. And just as a note, remember that whatever we do to the left, we do to the right. So when I subtracted 5.5, I had to subtract it from the right as well. Because this is an equation, both sides are equivalent, both sides are equal, so whatever we do to one side, we need to do to the other side of this equation. So, simple subtraction now, 6 minus 5.5. You can think of this as a decimal, 6 minus 5.5, but I think it's easier just to stick with fractions, because 6 minus 5.5, we know that 5.5 is less than 6, so we're going to still have a positive number. 6 minus 5 is 1, but we're still subtracting that 1/2, so that's going to leave us with 1/2. So p equals 1/2 in number one. And before we move on to number two, if you struggle with doing fraction, subtraction, or addition in your head, think about this. Off to the side here, we're going to write this with a common denominator to make it easier to add or subtract. So first, we're going to turn this mixed number into one single fraction. So if I have 5.5, that's 5 plus 1/2. Remember, because it's 5 and 1/2. So I really have 6 minus 5 plus 1/2. And I'm going to put parentheses around this because that half is with the 5. So if I have 6 minus 5 plus 1/2, parentheses may be a bit confusing, but I'm just subtracting the 5 and I'm subtracting the 1/2. So I can rewrite this without the parentheses as 6 minus 5 minus 1/2, because I'm subtracting that 5 and 1/2. 6 minus 5 we know is 1, so working left to right, we have 1 minus 1/2, which is simply 1/2. So that's what I did in my head over here, but if you want to write this all as one fraction, like I stated before, let's turn that 5.5 into a single fraction. 5.5 is 5 plus 1/2, and if I'm writing 5 in terms of halves, 5 times 2 is 10. So 10 halves plus 1/2, 5, 10 divided by 2 is 5, so there's my 5, plus my 1/2. 10 halves plus 1/2 is 11 halves, and now I'm going to change 6 in terms of halves. What divided by 2 gives us 6? That's 12. So I'll have 12 halves, that's my 6, minus my 11 halves, my 5.5. Subtracting the numerator, because my denominator is the same, I'm just going to keep it as is. 12 minus 11 is 1. So there's just another way to get 1/2. I wanted to just show you a couple different ideas so that whatever you feel more comfortable with, roll with that method. So let's move on to number two. In number two, we have m minus 1.5 equals negative 5/4. So we need to isolate the m. How we do that is we're going to get rid of this 1.5, and we're going to do that by adding it to the other side. If I add 1.5 to the other side, and remember I have to do that not just to one side but to both sides. So I'm going to also add 1.5 to both the left and the right. Negative 1.5 plus 1.5 is 0, so that's where I get my m minus 0, which m minus nothing is just m. So we have m on our left-hand side of the equation. So now it's time to work on the right-hand side. I have negative 5/4 plus 1.5. Now this might be a little confusing to think about, so let's turn this 1.5 into a single fraction. 1.5, I can simply multiply this 1 by 2, because 2 divided by 2 is 1. And 1.5 is like 1 plus 1/2. 2 halves plus 1/2 is 3 halves. 3 halves is equal to 1.5. So now on my left-hand side, I have negative 5/4 plus 3 halves. And I'm not quite where I want to be because look, my denominators don't match, so I'm not going to be able just to add my numerators. In order to add or subtract, I need the denominators to match. But that's an easy fix because, well, think about it. If I need these denominators to be the same, I can do one of two things. I can either divide this side by 2/2. So if I divide by 2 in the bottom, I'll get my 2. But if I divide 5 by 2, I'm going to get a decimal. So let's not do that method. Let's instead change this 2 into a 4. How do we change 2 to a 4? We multiply by 2. So if I multiply my denominator by 2, I need to also multiply my numerator by 2. So now I'm going to have that m is equal to negative 5/4 plus 3 times 2 is 6 over 2 times 2 is 4. 6/4. There we go. Now I have 4 in both my denominators, and I can just simply add these together. A negative 5 plus a positive 6 is simply going to be 6 minus 5, which is 1, and leave the denominator as is because it's the same. 1/4 is my solution for m. Let's move on to number 3. For number 3, notice that my negative 3/4 is multiplied by b. So in order to get rid of something that's multiplied, what do? We're going to divide. But think about dividing by a fraction. If I divide by this negative 3/4, that's the same as multiplying by its reciprocal. So as opposed to dividing by a negative 3/4, I'm instead, let's cover that up so you can't see that number so it doesn't get in our way. I'm instead going to multiply by a negative 4/3. And whatever I do to the left-hand side, I do to the right-hand side. Now, if you're confused on why I multiplied as opposed to dividing, if I have negative 4/3 times a negative 3/4, a negative times a negative, that's going to be a positive. So on my left-hand side, I'm now going to have a positive, which is what I want for b. I want b to be positive. And also look at this. 4 times 3 is 12. 3 times 4 is 12. I'm going to have 12 over 12. Negative 12 over negative 12, or negative times negative. We already said that that's going to be positive. 12 over 12 is just 1, and 1 times b, well, that's b. You could also think of it, if you want to cancel, 4 divided by 4 is 1, and 3 over 3 is 1. Negative times a negative, that's going to be a positive. So on the left-hand side, we're just left with b, and now we just need to multiply on my right-hand side, which multiplication you don't need the same denominator for. So we'll just multiply 2 right on into that numerator. 2 times negative 4 is a negative 8, so that's going to be a negative 8/3. So b is negative 8/3. We can leave as this fraction, but I believe the worksheet actually wants us to put it not as an improper fraction, improper meaning that the numerator is bigger than the denominator. It wants us to take that and convert it to a mixed number. So how many times does 3 go into 8? 3 goes into 8 a total of 2 times evenly, right? Because 3 times 2 is 6. But we know that 3 goes into 8 a total of 2 times. So this will be a negative 2. But how much is left over? 3 times 2 is 6. And 8 minus 6 is 2. So this is negative 2 and 2/3. A quick, really awesome double check. 3 times 2 is 6. 6 plus 2 is 8. Negative 8/3 is the same as negative 2 and 2/3. In number 4, we have x minus 3 equals negative 5.5. That 3 is subtracted from x, so in order to get rid of it, we're going to have to add it to both sides. So adding 3 to both sides will leave us with x on our left-hand side, and on our right-hand side, a negative 5.5 plus 3 is going to leave us with a negative 2.5. And that's going to be our solution for number 4. Easy way to think about this one. Ignore the 1/2. What's negative 5 plus 3? That's a negative 2. So if I had a negative 5.5 plus 3, that's a negative 2.5. Just some quick mental math. If you need to, draw out a number line. For now, let's go on to number 5. Number 5, we have x minus 1/2 equals 1/4. So how we're going to go about doing this one is we need to isolate our variable, which in this case is x, and in order to do that, we need to get rid of this negative 1/2. So we're going to add 1/2 to both sides. And by adding 1/2 to both sides, you can see that we're going to be left with x on our left-hand side, and that's going to be equal to 1/4 plus 1/2, or 1 1/4 plus 1/2. This is pretty easy to visualize. If I have 1 whole and 1/4, and then I add 1/2 to that, I have 1 3/4. So the solution for this is 1 3/4. If you need to convert everything to that same fraction, do that, and then take that improper fraction and change it back to a mixed number. But sometimes if you can just do it in your head and visualize it, it speeds up the process. Let's move on to number 6. In number 6, we have x minus 1/4 equals negative 6. What am I going to do? I'm going to add 1 1/4 to both sides. And by adding 1 1/4, we get rid of it on our left-hand side, so all we have is our x. And on our right-hand side, let's think about negative 6 plus 1. That's going to be a negative 5, but then we're still adding an extra quarter to that. So going a little bit past negative 5 on the number line by 1/4, we're not quite at negative 4 yet, but we're at negative 4 3/4. Number 6, we have negative 4 3/4. So here, a number line was actually pretty helpful for visualizing, because remember, we took that negative 6 and we added 1, but we still need to remember that we need to add that 1/4 still as well. So when working with the negatives and fractions, it gets a bit tricky, but if you need to, reference a number line. Or change everything into the same denominator before you solve. Let's move on to number 7. For number 7, we have 2 1/10 times n equals 1 1/6. Because this is multiplied by n, in order to isolate that variable, we need to divide or multiply by that reciprocal. But this is going to get a little confusing because this is a mixed number. So this is really 2 plus 1/10. So I don't want to go multiplying right off the bat. I'd rather make this all into the same fraction first. So 2 plus 1/10, writing that as the same fraction, I need to figure out how to change 2 into tenths. What divided by 10 gives me 2? That's 20 divided by 10 is 2, and I still have to add that 1/10. So 20 tenths plus 1/10 is 2 1/10. So here we have 21 tenths. So I'm going to actually rewrite this before I do any solving. I'm going to write this as 21 over 10 times n. And you know what I'm going to do? I'm going to change this into the same fraction as well. Because when I go to multiply by this, I'm going to multiply to something that's added together. So I'm either going to need to distribute, or I should just change this into the same fraction at the start to make it easier. Let's go ahead and do it that way. So 1 1/6, 1 plus 1/6 is equal to, well, changing 1 into terms of sixes, it's 6 over 6. So I have 6 over 6 plus 1/6, that's 1 1/6, which gives me 7/6. So on my right-hand side, I have 7/6. Now I know I'm going through this rather quickly explaining this because changing mixed numbers into improper fractions should be more of a review, but if you need to, Put the video at a slower speed, or if I'm explaining too much, feel free to skip ahead or speed it up just to go through the problem. But I want to note that this is equal to each other, and so is this, and these are also equal to each other because these are equations. So left-hand side is equal to the right-hand side. Now, in order to solve, I'm going to multiply by that reciprocal. So multiply by 10 over 21, multiply by 10 over 21. 10 cancels out, 21 cancels out to leave me with 1 times n, which is n, there's that identity. And then this looks like it's going to be messy because 7 times 10 is 70, but before we go doing some crazy multiplication, simplify first. 7 over 21, 7 goes into 21 3 times. So we can really rewrite 7 over 21 as 1 over 3. And look at this, both 6 and 10 are divisible by 2, so rewrite this as 3 and 5. As long as we're dividing the numerator by the same thing as the denominator, we can easily convert these fractions. So 1 times 5, multiplying my numerators together, is 5 over 3 times 3, which is 9. So we have 5/9 for number 7, which is a lot easier than doing 70 all over 6 times 21. So when you can simplify, do that at the start. In number 8, we have 9 1/3 equals 5 times n over 3, or 5/3 n. Again, what I want to do is I'm going to take this mixed number and change it into an improper fraction. 3 times 9 is 27. 27 plus 1 is 28. So this is 28/3. Again, 9 times 3 is 27, and I did this because 27 divided by 3 is 9. So 27/3 is 9. Add that to 1/3, that's 28/3. And that's going to be equal to 5/3 n. Now this one actually works out quite nicely because when we go to figure this problem out and isolate our variable, we're going to multiply that by that reciprocal, which is 3/5. And when I do that to my left-hand side as well, look what happens. My 3 cancels out with my 3, so I'm left with 28/5 as my improper fraction. However, this worksheet, when we're writing the answer, wants it as a mixed number, so how many times does 5 go into 28 evenly? That's 5 times. 5 times 5 is 25, and 28 minus 25 is going to leave me with 3. So that's going to be 5 3/5. Let's move on to number 9. For number 9, I have 5 2/7 plus k equals 2 27/70. This one seems a bit messy, but let's see if we can figure this out. We're going to start by trying to isolate that k, and in order to do that, we're going to subtract 5 2/7. Subtracting 5 2/7 from both sides, we're going to get rid of that 5 2/7 with the k to isolate the k, and that's going to be equal to 2 27/70 minus 5 2/7. Remember, the way we can think of these is 2 plus 27/70 and 5 plus 2/7. So because this is added together and I'm subtracting that entire thing, in order to make this easier, I'm going to write this problem splitting up those mixed numbers. So k is going to be equal to 2 plus 27/70 minus 5 plus 2/7. But if 5 2/7 is subtracted, well, let's erase this parenthesis and change this up. So I'm going to subtract 5 and then subtract 2/7 as well, because that whole entire quantity is subtracted. So let's start by working with our whole numbers. 2 minus 5 is going to be a -3. So I'm going to have -3, and I'm going to still have plus 27/70 minus 2/7. But the easiest way to rewrite 2/7 is, look, 70, 7 goes into that evenly 10 times. So I'm going to multiply both my numerator and my denominator of my 2/7 by 10. 2 times 10 is 20, and 7 times 10 is 70. So I get 20. Now, because I have that same denominator, I can easily subtract. 27 minus 20 is 7, and that's 7 over 70. So right now I have -3 plus 7 over 70. And we can easily simplify 7 over 70 down because 7 goes into 70 10 times is 1/10. Now this may seem like, oh, we can just do -3 and 1/10. But because there's an addition with a negative, when we make this into a mixed number, if we take -3 on the number line and add 1/10 to it, we're really somewhere between the -2 and -3. So that's really going to be -2 and 9/10. So we have -2 and 9/10 for number 9. Now let's move on to number 10. Number 10 is the last problem on this first page, and how we're going to start by solving it is we're going to add 3 and 1/4 to both sides of our equations. Whatever we do to this right-hand side, we need to do to the left-hand side. So we isolated the k on the right, and on the left, if we have 2 and 5/12 plus 3 and 1/4, let's split up all of these mixed fractions. So we'll have 2 and 5/12, which is 2 plus 5/12, plus 3 and 1/4, which is 3 plus 1/4. Addition, commutative, doesn't matter how we're going to add it. And we also don't need to leave those parentheses in like we needed to when we subtracted a mixed number, because everything's just added. So starting with 2 plus 3, that's going to be a 5. And then we need to add 5/12 still, because I haven't taken care of that. And we still need to add 1/4. But that's all equal to k. Next thing we got to do is we've got to figure out a way to add these two fractions together. And in order to do that, we have to find a common denominator. So 4 goes into 12 3 times. So I'll just multiply 4 by 3, and whatever I do in that denominator, I need to make sure I do in the numerator. Because if I just multiply that denominator by 3, 1/4 does not equal 1/12. Definitely does not equal each other. But 1/4 does indeed equal 3/12, which happens when I also multiply that numerator by 3. So if I have a 3/12 as opposed to a 1/4, 5 plus 3, adding the numerator, is 8. So I have 5 and 8/12 for my mixed number in number 10. But unfortunately, we're not quite done here because look at this. We can simplify further. So when you can simplify, just keep simplifying. 5 and 8/12, we can divide both the numerator and denominator by 2. Both are even. Actually, we can do even better. Both have a factor of 4. 4 goes into 8 and 4 goes into 12. So if I divide 8 by 4 and I divide 12 by 4, I'm going to have 5 and 2/3. 5 and 2/3 is the same thing as 5 and 8/12. It's just simpler. Let's move on to our next page. For number 11, we're going to need to add 4/9 to both sides. When I add that, I isolate my m on my left-hand side, and I get -2 and 67/90 plus 4/9, splitting up that mixed number with addition. However, because this is a -2 and 67/90, this isn't added together. -2 and 67/90 is -2 minus 67/90. That's -2 and 67/90. Both are negative. So when I add them together, we should add them like so, remembering to distribute that negative to each. If this was positive out in front, they'd both be positive. However, it's negative. Now, in order to simplify this down, I'm going to want to change 4/9 so that it's in terms of 90ths. And I can do so by multiplying both by 10. 4 times 10 is 40, 9 times 10 is 90, so 4/9 multiplying both by 10, this becomes 40/90. So now I have that m is equal to -2 minus 67/90 plus 40/90. And if I have a -67 plus a +40, that's going to leave me with a -27. So m is going to be -2 minus 27/90. And a negative minus a negative, I'll be able to combine this as one mixed number because they're both negative. So this is going to be -2 and 27/90. Unfortunately, we have a little bit more work because both 27 and 90 are divisible by 9, so we can simplify it down further. So we'll get -2 and 27 divided by 9 is 3 over 90 divided by 9 is 10. So -2 and 3/10. Moving on to number 12, 1/3 plus p, that's going to be equal to that 11/6 on the left-hand side. In order to cancel out this 1/3, I need to subtract it, and I subtract it from both sides. So I have 11/6 minus 1/3 equals p. Easiest way to do this is just convert this 1/3 in terms of sixes. So I'll have 11/6 minus, what do I have to multiply by denominator by to get 6? That's going to be 2. So I do the same to the numerator to give me 2/6. Again, I just multiply both by 2. So 11/6 minus 2/6, 11 minus 2, that's going to give us 9. So we have that 9/6 is equal to p, but we're not done yet because these are both divisible by 3. Dividing the numerator by 3, we get 3. Dividing the denominator by 3, we get 2. So that's 3/2, but we still have an issue because this is an improper fraction, where the numerator is greater than the denominator, but 2 goes into 3 one time with 1 remaining, so this is 1, and 1/2 equals p. Let's move on to number 13. For number 13, we're going to have to do a little bit of multiplying to cancel out this 11/8, or dividing, however you want to look at it. I need to divide by 11 and multiply by 8, so that's multiplying by its reciprocal, 8 over 11. And I need to do the same to my right side as well, 8 over 11. However, before I multiply, as opposed to converting this to an improper fraction, I'm going to write the mixed number out as addition, so I know that this 8/11 has to go with the 1 and the 13/64. So let's take a look at that now. We'll have 8/11 times 1 plus 13/64 equals v. Distributing that 8/11 through, 8/11 times 1 is 8/11, and that will get added to 8/11 times 13/64, and that's all equal to v. And look at this, 8 goes into 64 8 times. So I can rewrite this as opposed to 8 and 64, I'll rewrite it as 1 and 8. So I'll have 8/11 plus 1 times 13 is 13 over 11 times 8, which is 88. And that's all equal to v. Now, in order to add fractions, what do we need? We need a common denominator. So in order to create that common denominator, I'm going to need to multiply both my numerator and my denominator by 8. That's what's going to give me 88. So 8 times 8 is going to be 64 over 11 times 8, which is 88. And that gets added to 13 over 88, and that's equal to v. 13 plus 64, adding those two together, that's going to be a 77. So we'll get 77 over 88 equal to v. Look at this, simplifies down because both are divisible by 11. 7/8 is equal to v. There we have it. That's our answer, number 13. Moving on to number 14, 39 over 5 equals 2m. All I have to do is divide by 2. But look, dividing by 2, if you want to think of that as 2 over 1 times 1 over 2, same thing. Dividing by 2 is the same as multiplying by 1/2. So technically, we did multiply by the reciprocal. So I'll write this as multiplying by 1/2 because we're working with a fraction on the left-hand side as well, so it's going to be easier to see. Again, 2 divided by 2, that's equal to 2 times 1/2. 2 times 1/2, 2 over 2, that's 1. 1 times m is m. 1 times 39 is 39. And 2 times 5 is 10. 39 over m. 39 over 10 equals m. But this is an improper fraction. We want a mixed fraction, so we're going to see how many times does 10 go into 39. That's a total of 3 times with 9 left over, because 10 times 3 is 30. Add 9 more to get to 39. So 3 and 9/10 is equal to m. In number 15, we have n minus 3/4 equals negative 2 3/4. So I'm going to add 3/4 to both sides in order to isolate the n. That's half the battle right there. As long as we can get n by itself, then it's just a matter of manipulating in order to get that simplified answer. So if I have negative 2 3/4 plus 3/4, remember, think about that negative 2 3/4 as negative 2 minus 3/4. That is negative 2 3/4. It's a negative 2 and a negative 3/4 added together. But then, what are we doing to that? We're adding a positive 3/4 because we added that from the left-hand side. So take a look. Negative 3/4 plus 3/4, that's 0. So n is equal to negative 2 for number 15. That's really nice when numbers just work out like that. Let's move on to number 16. And number 16, 9/10 n equals negative 1 1/10. Now we can do the same thing where we split this up as negative 1 minus 1/10. Make sure to keep it in parentheses because we need to multiply. Or what I'm going to do is I'm just going to convert this to an improper fraction right off the bat. In order to get a negative 1 in terms of tenths, that's a negative 10/10. And if I have a negative 1 with that, that's negative 11/10 is negative 1 1/10. So I'm going to rewrite this as 9/10 n equals negative 11/10. Now, in order to isolate, we multiply by 10/9. That's right, the reciprocal. So we get n on our left-hand side, and that's equal to, my 10s will cancel out on my right-hand side as well, so we're left with negative 11/9. Negative 11's prime, so we're not going to be able to simplify this. However, we can convert it into a mixed number because 9 does go into 11 at least one time. So this is going to be negative 1 with how much was left over after we put 9 into 11? 2. So negative 1 and 2/9. Let's move on to number 17. For number 17, that negative 1 1/2 is additive, so in order to cancel it out, I'm going to add it to the other side. So I'm going to add a positive 1 1/2. So adding a positive 1 1/2 to the other side, I'll isolate b on my left-hand side, and that's going to be equal to negative 3 3/10 is negative 3 minus 3/10, and then I'm adding that to 1 1/2, so that's a positive 1 and a positive 1/2. Now I like to start with working with my whole numbers. Negative 3 plus 1 is going to be a negative 2. And then I have a negative 3/10 plus 1/2, so I'll rewrite that because I'm going to need to convert this 1/2 in order to have the same denominator as my 3/10, which I can just multiply both by 5. The numerator and the denominator of that 1/2, multiplying by 5, that'll be like adding 5/10. 1/2 is equal to 5/10. So now simplifying, we'll have negative 2 plus 3, negative 3/10 plus 5/10. Negative 3 plus 5 is a positive 2/10. So negative 2 plus 2/10. Can't write this as a mixed number, even though it looks like I can, because they're not the same sign. So think about that number line. If I have a negative 2 here, here's my negative 1, I'm adding 2/10. I'm going to fall somewhere within here, which is negative 1 and 8/10. So V is going to be equal to -1 and 8/10, which again simplifies down to -1, and both are divisible by 2, 4/5. -1 and 4/5 is my solution for number 17. Let's move on to number 18. For number 18, we have n minus 4/7 equals 3. Isolate that in by adding 4/7, and I have to add it to both sides of my equation. So n is going to be equal to 3 plus 4/7. Well, that's just 3 and 4/7. There we go. Leaving it as a mixed number was quite simple for number 18. Let's move on to number 19. Now, 19 looks a bit different than any other problem here. All they've done is they've put the k in the numerator. But this is the same as 9 over 65 times k. All they've done is bumped it up into the numerator. But in order to isolate, we're going to multiply by that reciprocal. So 65 over 9 is going to be multiplied to both sides. So covering up this 19 real quick so that we can see, all we're going to do is multiply both sides by 65 over 9. 65 cancels out with 65, 9 cancels out with 9. So we isolate our k on our left-hand side, and then this over here is going to require a bit of work. What I'm going to do is I'm going to change this mixed number. 1 plus 316 over 845 is, well, in order to change this into 845ths, that's 845 over 845 plus 316 over 845. Adding those two together, 845 plus 316, doing some mental math here, 6 plus 5 is 11, carry the 1, 1 plus 1 plus 4 is 6, 3 plus 8 is 11. So 1,161 over 845. So we have 1,161 all over 845 times 65 over 9. Now, this is definitely going to simplify down for us, but it might be a little bit hard to necessarily see how it's going to simplify down. But I know that 1,161 is indeed divisible by 9. And one really neat trick with 9 is if you add up all of these digits and that number is divisible by 9, then that number as itself, 1,161, is divisible by 9. So 1 plus 1 plus 6 plus 1, that's 8 plus 1, which is 9. 9 is divisible by 9, so I know for a fact that 1,161 is divisible by 9. And that's a little hard to do in my head, so feel free to use a calculator, or let's just do some long division. 9 goes into 11 once. Subtracting that, we'll have a 2. Bring down our 6. 9 goes into 26 2 times. That's 18. Subtract 18. That's going to be 8. Bring down the 1. 9 goes into 81 9 times. So 1,161 over 9 is really 129. So what I'm going to do is I'm going to write this as 129 over 1. And I don't have a trick necessarily for seeing if 65 goes into 845, but let's just check with long division. So I'm going to write this as 845 divided by 65. I know I'm writing it as the opposite of up here, whereas up here we have 65 divided by 845, so the 65 should actually be inside of this quotient. However, if I write it like this, I'll just be sure to put the number that I get here in the denominator of my fraction as opposed to the numerator, like I did in that first part. So 65 I know goes into 84 once. So if I subtract 65, 84 minus 65, 14 minus 5 is going to be 9, 7 minus 6 is 1. So that's 195. 65 goes into 195 evenly 3 times, because 65 times 2 is 130. 130 plus 65 is 195. So that's 13. So 845 divided by 65 is a 13, and I'm going to write that in my denominator. So dividing 65 by 65 is 1, dividing 845 by 65 is 13. So this is a lot simpler than before. We have that k is equal to 129 all over 13. Now it would be nice if we could stop here, but unfortunately we need to write this as a mixed number. So how many times does 13 go into 129? Well, not quite 10, because 10 would be 130, so I know that it's 9 and a little bit. So 13 times 9, 3 times 9 is 27, 1 times 9 is 9, plus 2 is 11, so 129 minus 117 is going to be 12. So this is 9 and 12 thirteenths. And look at that, we did all of that just without a calculator, using a simple trick and some long division and multiplication. Let's move on to number 20. In number 20, we have negative 9 19ths equals n minus 11. What we're going to do is add 11 to both sides. By adding 11, we isolate our n. So n is equal to negative 9 19ths plus 11. Now, unfortunately, we can't write this right off the bat as a mixed number because it's a negative and a positive combined together. But if we go to our number line, if we have a positive 11 and we're subtracting 9 19ths, we're going to be at 10, and how many 19ths do we need to add to 9 to get 19 19ths? That'll be 10. So we'll be at 10 and 10 19ths. And that's equal to n for number 20. And how I did that in my head, I knew that we had 9 19ths we were taking away. So if this distance between 10 and 11 is 1, and I have 9 19ths already accounted for, this has to be 10 19ths. So 10 and 10 19ths. Now moving on to the second to last problem, number 21. And if you found this video really helpful and you've stuck with me this far, go ahead and give me a thumbs up button and share it with your peers. But let's go ahead and finish out these last two problems. Isolate my variable, which is n. I'm going to subtract 4/3. So I have 1/3 minus 4/3 equals n. Same denominator, so just go ahead and subtract the numerators. 1 minus 4, that's going to be a negative 3. So I have negative 3/3 equals n. Negative 3/3 simplified down is negative 1. So negative 1 equals n for number 21. In the last problem, number 22, I'm going to have to do multiplication, and I'm going to multiply by that reciprocal. So multiplying by 11/13 to both sides. And the nice thing about this is that 13 goes into 26 2 times. So we'll write this as 1 and this as 2. And 11 goes into 33 evenly 3 times. So when I divide 11 by 11, I get 1. And when I divide 33 by 11, I get 3. 1 times 2 is 2. 1 times 3 is 3. And there's negative in here. So that's going to be a negative 2/3. So negative 2/3 is my final solution on this worksheet. If you have any questions at all, please feel free to let me know in the comments below. And as always, don't forget to like, subscribe, and share.